We're basically swimming in an ocean of information. Every single click, every purchase we make, even our own heartbeats can be recorded and stored. But in this gigantic, endless sea of data, how in the world do we find the things that actually matter? How do we cut through all of that noise to find a clear, useful signal?
All right, let's just jump right into it. The amount of data we're all creating is, well, it's exploding. We're talking about everything from medical records to what's trending online, and the sheer volume is just staggering. But here's the catch. Most of this information on its own isn't really that useful. It's just raw, messy, and absolutely full of noise.
I really love this analogy because it's so true. Raw data is a lot like gold ore. Sure, it's incredibly valuable, but all that value is locked away inside. You can't just pick up a random rock and expect to buy something with it, right? You need a pretty powerful process to sift through tons and tons of dirt just to find those little flecks of precious metal.
So that brings us right to the main event, the central question of all this. We've got this mountain of digital ore, so what's our pickaxe? What's our high-tech version of a pan for sifting gold? What's the process we use to pull out real, tangible value from all this mess?
Well, the answer lies in a field called data mining. And this is the cool part. This is the technology that acts like our super sophisticated refinery. It's what turns all that raw information into something we can actually use to make really important decisions.
So what exactly is data mining? Think of it as the process of using automated tools, borrowing all sorts of powerful techniques from statistics and machine learning to just dig through enormous datasets. It's designed to automatically spot these hidden patterns, these surprising connections, and genuinely useful pieces of info that a person, no matter how smart, might never, ever find on their own.
Now, here's where things get really interesting, because there's been a huge shift. You see, early data mining was purely data-driven. It would find any pattern it could, which was kind of cool, but not always useful. The modern approach, though, is domain-driven. The whole goal has changed. It's not just about finding something interesting anymore. It's about finding something that's actually relevant and helpful in a specific area, like medicine or finance.
And that leads to the real prize, the whole point of the exercise, discovering what we call actionable knowledge. This isn't just a fun fact or a piece of trivia. We're talking about an insight that's so powerful it can directly lead to a decision, something you can turn into a real-world action. It doesn't just give you an answer, it helps you ask an even smarter question the next time around. That's the new gold standard.
Okay, to make this less abstract, let's look at a super high-stakes, real-world example where this kind of actionable knowledge can literally be the difference between life and death. Let's talk about predicting heart disease. The challenge itself sounds simple, but it's incredibly complex to actually solve. Can we use data mining and AI to look at a patient's health information and accurately predict their risk of developing heart disease, potentially flagging it way earlier than we ever could before? So, this is what the AI has to work with. It's like a snapshot of a patient's health profile, looking at 14 different factors, things you'd expect, like age and cholesterol, but also stuff like resting blood pressure and maximum heart rate. The AI's job is to look at all these variables at once and find those hidden patterns that scream high risk. And here we go, the results. Researchers threw a few different AI models at the problem. And as you can see, one model, called XGBoost, came out on top. It hit 88% accuracy. That means it was right 88 out of 100 times. And those other columns, precision, recall, and so on, they're just different ways of measuring performance. And they all confirmed that this model wasn't just accurate, it was consistently solid.
An 88% success rate is an absolute game changer. Think about it. For every 100 patients, this AI can correctly identify the risk for 88 of them. This gives doctors an incredibly powerful new tool for early intervention. It turns a routine health screening into a highly targeted, potentially life-saving prediction. Now, a success like that is incredible, for sure. But honestly, it's just the beginning. This all points to a future where AI isn't just a tool we check in with for prediction. It's pointing to a future where AI becomes an active partner in the analysis, which you might call an autonomous analyst. So this next frontier is something called agentic AI. This is where the AI basically gets a promotion. It graduates from being a passive tool to being an active partner. An agentic AI can come up with its own plan for an analysis, run all the steps it needs to get insights, and even check its own work to make sure it's valid, all without a human needing to hold its hand every step of the way.
This quote just nails it perfectly. We are watching a fundamental shift happen right now, from thinking of AI as just a tool that we use to thinking of it as an autonomous analyst that we collaborate with.
It completely changes the whole human-machine relationship.
But, with all this incredible promise comes great responsibility. This technology isn't some magic bullet. As we give AI more and more autonomy, there are some really significant ethical and technical challenges that we absolutely have to tackle.
First up, we have the black box problem. The issue is that a lot of these advanced AI models can give you a stunningly accurate answer, but they can't always explain how they got there. And in a field like medicine, that's a huge deal. If an AI suggests a specific treatment, a doctor needs to understand the why behind it. So a massive area of research is building systems that aren't just accurate, but also transparent.
Then there's the huge issue of algorithmic bias. You see, an AI is only as good as the data it's trained on. So if our historical health data has biases baked into it, maybe certain groups are underrepresented, the AI can actually learn those biases. It could end up creating systems that are less accurate for some people, which would just make existing health inequities even worse.
And of course, we have to talk about data privacy. To be effective, these models need massive amounts of data, and a lot of it is deeply personal, sensitive health information. Making sure this data is protected, that it's secure, and that it's used ethically is frankly non-negotiable.
So when we look toward the future, it's pretty clear that the relationship between people and data is going through this profound change. And it's important to remember, this isn't about replacing human experts, it's about making them even better.
This right here is the key takeaway. For decades, we've been using tools to help us find answers hidden in data. Now, that whole dynamic is starting to flip. The AI is going to get better and better at finding the answers, and that frees up our human brains to focus on a much more important, much more strategic task, asking better, smarter, and more creative questions in the first place. Which leaves us all with one final thought. In a world where an AI can analyze data at a scale and speed that we can barely comprehend, the most valuable skill we can have won't be about finding the right answer. It'll be about asking the right question. So the only thing left to ask is, what questions will you ask?